Okay, as Jean has already alluded, I'm going to talk to you about boat lifts because it actually combines my passion for lifts with my passion for boats, and I don't know which is the strongest, to be honest. Okay, once upon a time, England's canals and rivers were the motorway of their day, and they take some believing. This is rush hour in Congleton, believe it or not. And you can see there from a map of the waterways, most of which still exist, you could get anywhere around the UK by boat. Some famous companies popped up as well, companies like Fellows Morton and Coles, who own huge fleets of narrowboats, and they used to move stuff about the country. And this used to go on day and night, day in, day out. In fact, here is an FMC boat being unloaded in Hemel Hempstead. Was actually the Rose's Jam factory down there. Such was the industry that, in fact, people lived on their boats. And this is a traditional back cabin from a boat, 10 foot long. Very often there are 2 or 3 kids. Very often the kids used to sleep on the cargo. But you used to eat, sleep and wash in that back cabin. These days, though, most rivers and canals are used for leisure purposes. And in fact, that's my boat, Lola, that Gina just referred to. I'm going to talk about 3 boat lifts. The Anderton. The Anderton is often called the Cathedral of the Canals. It's up there in the northwest on the Trent and Mersey Canal. Then I'm going to look at the Foxton boat lift, built in 1901, only lasted 10 years and was scrapped eventually in 1928, but not because it was a failure. I'll go through that when we get to it. And then, of course, the Falkirk wheel up in Scotland, still operational, opened in 2002. So, the Anderton. Originally, a flight of locks was considered for the task, but this was discounted due to the time it would take for the boats to get through the locks. So if anyone's ever been on a narrow boating holiday, if you're waiting for a lock, you could be there for a long time. The amount of space required was a problem, and also the large amount of water that will be lost from the canal, the Trent and Mersey, down onto the River Weaver. Back. How do I get the video to work, Richard? Ah, lovely. Cheers.
A canal connects 2 bodies of water that may have different water levels. Ships traveling through the canal move from one water level to another through a lock, a rectangular chamber with watertight gates at each end. In the lock, the level of water can be raised and lowered by a system of valves and water passages. Suppose a ship is traveling from the higher water level to the lower. First, an operator at a nearby station opens the lock gates at the high end. The ship enters the lock, and the lock gates are closed. Next, the lock operator opens one or more valves so that water from the lock slowly drains into the lower section of the canal. When the water in the lock is level with the lower water, the operator opens the gates and the ship sails through. To move a ship upstream, the procedure is reversed.
Locks take a lot of time. You normally allow at least 1/4 of an hour if you've got a straight lock. When you arrive at it, the water's set in your favour and you're going through. So if you can imagine a flight of locks and queuing boats and single boats being able to go in them, you could see what the waiting time will be. So the Anderton was the solution. It was built in 1875, and it's a very impressive 60-foot high structure, as you can see there. It's that high to allow it to clear the 50-foot difference in height between the 2 water levels of the River Weaver and the Trent and Mersey Canal. The entire structure is 85 feet long, and 49 foot wide. The aqueduct itself that feeds the lift is 165 feet long. Each tank or caisson, as we call them, weighed a staggering 91 tonnes, empty, and 252 tonnes when flooded. These were 75 foot long, 15 foot 6 wide, and 9 foot 6 deep in the middle. and they were bigger enough for 2 boats. So you can imagine passage straight away. You've got 2 lifts there for a start, and it replaced 9 locks. In 2001, the lift was restored back to full hydraulic operation. It was originally a hydraulic operation. In 1908, the structure was amended, and you can see on top there loads of pulleys, and it went to traction in 1908. And that was because the rats kept eating the leather seals of the pistons. The replacement hydraulic ram shafts replicate the original. They're 3-foot diameter and 56 foot long when retracted, and 106 foot long when they're fully out. Each ram weighs approximately 50 tons. It was designed by a chap called Edwin Clark, and he went on to design bigger lifts on the continent, including the lifts at La Louvière in Belgium. There's another photograph of you can see the diverters a lot easier there. And here you can see the pistons. That's it. You see the pistons there. Oh, that's go about one. The piston there, that is a complete piston, and it's sitting in there, going right up. It's an amazing piece of work. And that's the view up onto the top deck when you're actually in the caisson in a boat, and you can see the pulleys all arranged at the top there. A few lifties went in 2009 to go and have a look at it. That was me. Clearly someone wasn't that interested. And he sat in the audience today. Moving on to the Foxton Lift. The Foxton Incline Plane, as it's called, was installed on the Leicester branch of the Grand Union Canal. The flight at Foxton was built in 1810, and the top summit route opened 4 years later. So back in August 2014, last year, it celebrated its centenary. A trip through the then 10 locks took about 45 minutes to negotiate the 75 feet, and that's if you've got a straight run. It's just under 23 metres of hill there, and it uses 25,000 gallons of water. But if there's a queue, you can be held up for hours. As you can see, you can only get 1 boat in each lock, and once a boat's in there, there's no passing, there's no side channels where you pass. You're just in a ladder, so you've got to wait for the whole thing. In the days when canals were used as a means of transporting cargo, and they were significantly busier than they are today for leisure use, this was bad for business. The boat width in the locks, as I say, is restricted to 7 foot. So boats which used to work with something called a butty, which there was a boat with an engine and there was another replica barge beside it, which didn't have an engine. It was just towed around or double-breasted, as it's called. And of course, the butty would have to negotiate the flight separately. So boats using the locks were also restricted to a maximum of 20 tons, so a solution was needed. And this was the solution. This is a plan of the Thomas Lift. Unfortunately, with the coming into the railways, competition was starting to bite. Fellows Morton and Clayton, the company I mentioned earlier, wanted to use bigger boats to take coal from the north to the London factories. And they promoted a takeover of the Leicester line of the canal by the Grand Junction Canal Company. The takeover was successful, and FMC promised to put more narrowboats on the canal until the locks at Watford Gap and Foxton could be widened. The engineer, Gordon Thomas, was put in charge of the project. However, eventually wide locks were dismissed as using too much water from the canal's summit pound, and his solution was to build the lift. This is the lift under construction. It was built in 1901 by Gwynns of Hammersmith, and they got the job because they proposed using hydraulic power for the gates and the ancillary equipment. It consisted of 2 tanks or caissons linked by a wire rope, and a steam-driven winch at the top wound the rope onto one side of its drum, simultaneously letting it out on the other. And this raised and lowered the tanks. Each tank was full of water and weighed 230 tons, with or without a boat, as boats displaced their own weight in water, the Archimedes principle. 2 boats again could fit into each tank, and the gradient in the system was 1 in 4, so quite steep. At the top level, the caisson was hauled over a slight hump, taking the weight off the system, which allowed the bottom boat, which obviously was coming into the water here, the bottom caisson, sorry, to just sink down. But if you go back to this line, you see the green towel line there. In fact, that was quite a thin line, and all that did was just pull the top one over its hump to get it running. Operation was fairly simple. Assuming your boat's at the bottom, you took your boat into the tank. The operator would close a guillotine gate behind you, and then using the ship's telegraph would tell the control station at the top to start. There's a 25 horsepower steam engine, and you just started ascending the hill. And as the one started ascending, as I said, the tail rope pulled the other one over its hump at the top, and then that started descending. And then when you got to the top, in those days, you reattached your horse, and off you went. It was all over in about 9 minutes. Unfortunately, the lift had worked well, but it only lasted 10 years. And the reason it only lasted 10 years is because the railways started buying the canal companies, and then taking the traffic onto the railways, and just let the canals go into rack and ruin, which is why they're now used purely for leisure. So, again, that's a plan from above, and you can see it's this rope here. As you start pulling this one up, it will pull up that one just over a slight hump. It's very ingenious, because obviously the bottom one will come out of suspension because it's actually got to float down into the water. Okay, so the Falkirk wheel. The Millennium Link was an ambitious £84.5 million project with the objective of restoring navigability across Scotland and through the historic Forth and Clyde and Union Canals, providing a corridor of regenerative activity in Scotland. The major challenge that was faced was to link the two canals, which was the Union and the Forth and Clyde, as you can see here. They were 35 metres apart, and historically the two canals have been joined again by a flight of locks, 11 locks in fact, but again with the railways taking over the canal companies in 1933, they were just closed down and let go to rack and ruin. So this was the idea, a complete rotating arm with two caissons, one in each loop at the bottom there. And it's beautifully balanced, because obviously, again, the weight of water and a boat in one will equal the other side. In fact, to get it to rotating, you just slightly overfill one caisson just to let it start to rotate. Okay, you can see a boat on there in one of the caissons there. The various parts of the wheel were actually constructed and assembled like a giant Meccano set at Butterley's Engineering Steelworks in Derbyshire. The team there carefully assembled the 1,200 tonnes of steel, fitting the pieces together with an accuracy of 10 millimetres. This ensured a perfect final fit, and in 2001 it was taken to Scotland and installed. Over 15,000 bolts matched perfectly with the bolt holes, and it was opened by Her Majesty the Queen on the 24th of May 2002. Here's another view with that side raising. So while I finish off, you can see the video of it rotating there. It's quite slow. It lies at the end of a reinforced concrete aqueduct, rather like the Anderton did. It had to have an aqueduct out to it. It works on the Archimedes principle of displacement, as I said earlier. And that is the mass of the boat and sailing into the gondola will displace the exact proportional amount of water. Each gondola runs on small wheels that fit into a single curved rail fixed on the inner edge of the opening on each arm. In theory, this should be sufficient to ensure that they always remain horizontal. But any friction or sudden movement could cause the gondola to stick or tilt. To ensure that this could never happen and that the water and the boats always remain perfectly level throughout the whole cycle, a series of linked cogs act as a backup. So just to conclude, Hidden at each end behind the arm nearest the aqueduct are two 8-metre diameter cogs, to which one end of each gondola is attached. A third exactly equivalent sized cog is in the centre, attached to the main fixed upright. Two smaller cogs are fitted in the spaces between, with each cog having teeth that fit into the adjacent cog and push against each other, turning around the one fixed central one. The two gondolas being attached to the outer cogs will therefore turn at precisely the same speed, but in the opposite direction to the wheel. Thank you very much.